Okay, I hope that you got your math book, and if you will please open your math book up to page 27. And on page 27, you're going to see the page that I have here on the screen. Today's number is 7. Today's number is 7. I would like you to take a minute now, and on your page, today's number is 7, I want you to make a T-chart like this. And at the top, I want you to put the number 7. And over here, I want you to put the addition sign. And over here, I want you to put the subtraction sign. So when we think about our number 7, I'd also like you to get out 7 connecting cubes. And I'm going to do that right now too. 7 connecting cubes. And they don't have to be the same color. If you want to have different colored ones, I'm going to use different colored ones today. Alrighty, so you're going to take your 7 connecting cubes like this, and you're going to make a cube train. Let's make a cube train. Alrighty, so here we've got 7 connecting cubes. Let's count them together. 1, 2, 3, 4, 5, 6, 7. So we're thinking about that number 7. And what I'd like for you to do is I'd like you to take a few minutes, use your connecting cubes, and come up with 3 addition equations that equal 7. 3 different ways that you can add up to equal 7. Now they've given you some addition equation examples at the top. 5 plus 2, 5 plus 1 plus 1. Those are all addition equations that equal 7. I'd like you to come up with 3 of your own, thinking about what 3 numbers could equal up to 7. So I want you to pause the video, take a few minutes to think about that, and then we'll come back together and I'll put some down here on my chart as well. Alrighty. So you used your connecting cubes, and you looked for different ways to take these 7 cubes and make equations. Maybe some of your equations are just like my equation. So let's take a look and see. So the first one is 3 plus 4. Does 3 plus 4 equal 7? Well, let's take a look and see. So I've got 1, 2, 3 here, and 1, 2, 3, 4 on top. So if I put them together, let's see, do they equal 7? So let's see. 1, 2, 3, 4, 5, 6, and 7. So 3 plus 4 does equal 7. So here's my question. Can you turn it around? Can you add 4, have 4, and add 3 more and still get 7? Well, let's see. If I've got 4 here, 1, 2, 3, 4, and I bring along this 3, 1, 2, 3, and put them together, do I still have 7? Let's look and see. 1, 2, 3, 4, 5, 6, 7. So what we learn is how we add the numbers. In whatever order we add them, they're still going to equal the same amount. So order does not matter. All right, now let's take a look at 6 plus 1. So if I've got 6 cubes, 1, 2, 3, 4, 5, 6, and I add 1 more cube to it, you can see I've got 7. All right, now this bottom one here, 2 plus 5, that is just a different order of 5 plus 2. And we've already said order doesn't matter. So we know that 5 plus 2 equals 7. So 2 plus 5 must also equal 7. But let's make sure just to see. Let's take our cubes. I've got my 2 here. And I'm going to bring along 5 more. 1, 2, 3, 4, 5. Put them together, and let's see. 7 again. So really, we've learned order doesn't matter. All right, now I want you to take a few minutes, and instead of using your connecting cubes, I'd like you to use either your number line or your hundreds chart. And I'd like for you to think about a number that's bigger than 7. And then I want you to figure out, if you count back, how much it takes to get to 7. So for example, one of our subtraction equations here is 10 minus 3. And that, we know, equals 7. So I'd like for you to look for some more subtraction equations that equal 7. I'm going to give you a few minutes, pause the video, and then we'll come back and talk about it. So we're continuing to look at our today's number, which is 7. And we already did 3 addition equations that equal 7. And now I've asked you to make 3 subtraction equations that equal 7. So there was a sample one here at the top, 10 minus 3. So let's see, I have written, and maybe some of yours are just like mine, I have written 8 minus 1, 9 minus 2, and 11 minus 4. So let's take a look, let's use our hundreds chart on this first one, and see, we'll start here at the bottom, 11 minus 4. Let's use our hundreds chart, and let's make sure that 11 minus 4 does equal 7. So I'm going to show you, I'm going to use my hundreds chart, and I'm going to show you what my thinking was while I was doing this. So I started with 11, and I wanted to figure how many it takes to get back or to take away to get to 7. So I counted back. So I was at 11, I jumped up here, 1, 2, 3, 4, and I landed on 7. So I knew that 11 minus 4 is going to equal 7. Alrighty, now you might have chosen, instead of using your hundreds chart, you might have decided, I think I might like to use my number line. Well, your number line is on the back of your hundreds chart. So if you take a look at your number line here, I had an equation of 8 minus 1. So does 8 minus 1 equal 7? Well, let's take a look. So here we are at 5. Let's jump up to 8. So 6, 7, 8. Here we are at 8. Now, if I jump back 1, or I subtract 1, or you can call it taking away 1, will I land on 7? So here I am at 8, I take away 1, and I'm at 7. So 8 minus 1 does equal 7. All right, let's use our number line again and try 9 minus 2. So if you take a look, here's 9, right next to number 10. And I'm going to jump back 2. So I'm going to go 1, 2, and I'm going to land here. So let's see, does that equal 7? Well, we know this is 5, this is 6, so that must be 7. So yes, 9 minus 2 on our number line does equal 7. Alrighty, good job, guys. So if you will take a look down here at the bottom, the last thing you're asked to do on this page is to write the number 7. We've got to think really hard. Well, we know starts with 7. It starts with an S. So S, E, S, V, V, N. There we go. There's our way to write 7. Thank you for watching. Now we're going to complete page 28, which is about clocks. So you can see that there's a whole bunch of analog clocks, and you have to write the time in digital. So before we do that, I want to make sure we go back over the times that we did in our first video. So let's take a look at our clock. Let's start back here at 3 o'clock. This is the first time we started with, remember? We had the big hand on the 12 and the little hand on the 3, or also known as the minute hand on the 12 and the hour hand on the 3. And when you write that in digital, remember, digital is 3 is the first number, and there are those 2 dots on top of each other, and then o'clock is 2 zeros. So 3 o'clock looks like that. That's what it looks like in analog. That's what it looks like in digital. Let's try one more just to make sure we're ready to do our workbook, page 28. Alrighty? Let's try 6 o'clock. On our analog clock, 6 o'clock looked like that. Trying to make that straight. Alright. Our minute hand was pointing to our 12. Our hour hand was pointing to our 6. And when we write that in digital, remember, the hour goes first, so we put that, which is a 6, our 2 dots on top of each other, and then 0, 0 means o'clock. So here we go. We've got 6 o'clock. Right there. Okay, take a few minutes, complete page 28, and then you're probably going to want to tear that out and put that in your orange folder to return to your teacher on Friday. Have a great day.